Hello everyone, I am Madhura L from first sem Honda section. Today's subject is mathematics and the topic is Cartesian coordinate and polar coordinate. Cartesian coordinate system. The coordinate system is used to locate the position of a point in a plane using two perpendicular lines. Points are represented in the form of coordinates x, y in two dimensions with respect to x-axis and y-axis. In this article, we will learn about the Cartesian coordinate system. To understand the need of coordinate system, let us consider an example. Suppose Reena is a girl in your class and she sits in the third column and the fifth row. Then this position can be represented as 3, 5. Two axes. Vertical axis and perpendicular axis are reference lines of a rectangular system from which distances are measured. They are obtained as follows. Explanation for this quadrant and the diagram. Take two number lines x, x dash and y, y dash. Place x dash in horizontal and write the numbers on it as we write in the number line. Similarly, place y dash in vertical and proceed writing numbers on it as we write in a number line. Combine both the lines in such a way that the two lines cross each other at their zeros or origins. The horizontal line x dash is called the x-axis and the vertical line y dash is called the y-axis. The point where x dash and y dash cross is called the origin and is denoted by O. Since the positive numbers lie on the directions OX and OY, OX and OY are called the positive directions of the x-axis and the y-axis respectively. Similarly, OX dash and OY dash are called the negative directions of the x and y-axis respectively. Abscissa and coordinate. The x-coordinate of a point is its perpendicular distance from the y-axis measured along the x-axis and it is known as abscissa. The y-coordinate of a point is its perpendicular distance from the x-axis measured along the y-axis and it is known as ordinate. In writing the coordinates of a point in the coordinate plane, the x-coordinate comes first and then the y-coordinate. We place the coordinates in brackets as x, y. The coordinates describe a point in the plane uniquely. It implies 3, 1 is not equal to 1, 3 or in general x, y is not equal to y, x. Consider an example point 5, 6. Here abscissa is 5 and coordinate is equal to 6. Example problems for the Cartesian coordinate system. Example 1. Locate below points on the Cartesian coordinate system. Also mention the quadrant points belong to 2, 3, minus 3, 1, minus 1, 5, minus 2, 5, 0, 0. So 2, 3 lies in first quadrant, minus 3, 1 lies in second quadrant, minus 1.5, minus 2.5 lies in third quadrant, and 0, 0 is in the origin. Example 2. If the vertices P, Q, R of a triangle PQR are rational points, which of the following points of the triangle PQR is or are always rational points? And A is centroid, B is incenter, C is circumcenter, D is orthocenter, and the solution for this is given below. Example 3. Let A 2, minus 3 and B minus 2, 1 be vertices of a triangle ABC. If the centroid of this triangle moves on the line 2x plus 3y is equal to 1, then the locus of the vertex C is the line. And the solution is, let the third vertex be x1, y1, then centroid. G is equal to x1 plus 2 minus 2 by 3, y1 minus 3 plus 1 divided by 3. That is G x1 by 3, y1 minus 2 by 3. Given centroid of triangle moves on the line 2x plus 3y is equal to 1. So 2x1 by 3 plus 3y1 minus 2 whole divided by 3 is equal to 1. That is 2x1 plus 3y1 is equal to 9. Locus of x1, y1 is 2x plus 3y is equal to 9. Let us look into the polar coordinate system. When each point of a plane of a two-dimensional coordinate system is decided by a distance from a reference point and an angle is taken from a reference direction, it is known as the polar coordinate system. Pole is equal to the reference point. Polar axis is equal to the line segment ray from the pole in the reference direction. In the polar coordinate system, the origin is called a pole, and the graph is given below. Here, instead of representing the point as x, y, we can express it as a polar coordinate or theta, where the value of r can be negative. The value of angle changes based on the quadrant in which the r lies. So the quadrant 1 value of that is calculated value. 2, add pi to the calculated value. 3, add pi to the calculated value. And 4, it goes the same. And note, for the above table is in the Cartesian coordinate system, the distance of a point from the y-axis is called its x-coordinate and the distance of a point from the x-axis is called its y-coordinate. Polar grid. Polar grid with different angles as shown below, and the grid is given on the right side of it. Also, pi radians are equal to 360 degree. 3D polar coordinates. 3D polar coordinates or spherical coordinates will have 3 parameters, distance from the origin and 2 angles. The 3D polar coordinates can be written as r, phi, theta. Here r is equal to distance from the origin and phi is equal to the reference angle from xy plane and theta is the reference angle from z axis. And for example, the graph is given below. Polar coordinates examples are: example 1, convert the polar coordinate 4, pi by 2 to a rectangular point. The solution is r, theta is equal to 4, pi by 2. We know that x is equal to r cos theta, then x is equal to 4 cos pi by 2, x is equal to 4 cos 90 degree, x is equal to 4 into 0. So x becomes 0 and y is equal to r sin theta. So y is equal to 4 sin pi by 2, y is equal to 4 sin 90 degree, y is equal to 4 into 1. So finally y is equal to 4. Hence the rectangular coordinate of the point is 0, 4. Example 2. For the polar coordinates, convert the rectangular or Cartesian coordinates 2, 2 to polar coordinates. Solution is x, y is equal to 2, 2. R is equal to whole root x square plus y square is equal to whole root 2 square plus 2 square, which becomes whole root 4 plus 4 is equal to whole root 8. Then whole root 8 becomes 2 root 2. Y by x is equal to 2 by 2 is equal to 1. Theta is equal to tan inverse of y by x, which gives tan inverse of 1. The final answer is pi by 4. Hence the polar coordinates are 2 whole root 2, pi by 2. And note is, we know that the value of r can be negative 2. That means r is equal to plus or minus 2 root 2. Also tan inverse of 1 will also take many values such as pi by 4, 5 pi by 4, minus 7 pi by 4. Hence the possible polar coordinates of a point 2, 2 are 2 whole root 2, pi by 4, minus 2 root 2, 5 pi by 4, 2 whole root 2, minus 7 pi divided by 4. Cartesian coordinate applications. A few examples of coordinate geometry applications are shown below. It's used to figure out how far 2 points are apart. Second point, it is used to calculate the dividing line ratio in the m:n ratio. It is used to find the line's midpoint. It's used to figure out how big a triangle in the Cartesian plane is. And applications for the polar coordinates are: two-dimensional polar coordinates play a significant role in navigation either on sea or in air. If equations are expressed in polar coordinates, then calculus can be applied. And thank you everyone for watching the video.